Welcome to the HACARUS webinar series. My name is Adrian Sosna, CMO, and I will today talk to you about the topic deep learning and sparse modeling. How are they different and can they be used together? For first timers, let me start off by giving a very brief overview about HACARUS. We are a Kyoto-based AI specialist firm that builds AI solutions primarily for the medical and manufacturing industries. Our specialty is data analysis using sparse modeling, and we focus on building explainable AI solutions that help our customers and partners understand why a model has made a certain prediction or recommendation. We span all the way from FPGA applications and implementations up to cloud. Our non-deep learning based approach allows us to provide edge-side learning and inference. Today, I want to talk to you about machine learning, deep learning, and sparse modeling. First, let's look at what we're trying to achieve with deep learning and what we're trying to achieve with sparse modeling. Then let's look at some practical applications for what we can do with sparse modeling. And finally, some examples of how potentially you can actually use both techniques together. Starting from the beginning, what is learning? Well, when we talk about learning in machine learning, we really talk about assigning relationships between different data types. In this example, we prepare a large amount of input data X, generally the more the better, and we assign a label to this data, Y. You throw X and Y into a deep learning system, and voila, learning is complete. But what is it that actually has been learned? Well, when we're using deep learning, what we're actually doing is we're learning functions. Now, functions are the correspondence between input X and output Y. In the case of machine learning, functions are identified from huge data sets. So when we give data X, that data helps us identify how to determine Y. With sparse modeling, on the other hand, we take a different approach. Let's start by talking about what does sparse mean? Well, sparse is defined as in short supply or thinly dispersed. Really, what we're talking about here is understanding the key qualities or key features of data. Now, one very famous technique in sparse modeling is using lasso. And it's been used for things like increasing the imaging speed and resolution of MRI scan by assuming data or filling in the values that are missing, or for applications such as photographing black holes that made news a few years back. Now, what are we actually doing? Well, we're identifying how the observed value Y is given by what kind of X value. So really, we're looking to understand complex data from a small number of integrated causes. Extracting causality from data is really what sparse modeling is all about. Now, with machine learning, or specifically deep learning, what we're trying to understand is when given data X, we're looking to infer Y. This is a forward problem. With sparse modeling, on the other hand, when given observed value Y, we're looking to find the cause, X. It's an inverse problem. So we're not looking for how, we're looking for why. So what can be done with sparse modeling? On this slide, we've summarized two techniques for its practical usage. The first one being a lasso, and the second one being dictionary learning. Now, the lasso approach is used for things such as increasing the speed and improving the quality of MRI imaging, or in the famous example of the first ever image of a black hole, but it can also be used for X-rays. We try to find X under the premise that most components are zero. In a nutshell, the pixel difference between adjoining pixels are zero in X-rays, so we can use a premise that most points are straight. Bones only change direction at the joints when we are doing our predictions. With dictionary learning, we think that Y can be represented by a combination of a few patterns. This is used in our visual inspection tool Spectro for anomaly detection. The basic challenge is to create a dictionary with as few components as possible to then check with new data for anomaly detection. You can learn the specifics of both these examples in several code science articles by HACARUS, so please check them out. Now let's look at how to integrate deep learning and sparse modeling. Well, in a paper on variational sparse coding, it said that if you make the VAE a latent code sparse, it will become latent code that is highly interpretable, meaning explainable. When using VAE, it learns the Gaussian distribution and then returns the original signal. If you change the Gaussian distribution to a spike and slab distribution, you can use sparse modeling. If you then use the spike and slab model, the chances of it being zero is very high, so it's a good example of using sparse modeling. So what are the applications? Well, we conducted a small experiment and here are the results. First thing, performance does not decrease even if the dimension of the latent space is increased, meaning we can avoid problems with overlearning. Secondly, interpretation of latent code becomes very high. If you change the latent code, the sleeves disappear, and if you change the value of the blue dot, the image changes and the sleeves disappear. Therefore, it's very easy to understand the correlation between input values and you achieve explainability. In conclusion, machine learning, deep learning, and sparse modeling differ completely in sense of purpose. Sparse modeling is an analytical method that extracts the essence of data by assuming the sparsity of the data. You can do various things other than lasso, and it's very useful for imaging data. There are recent studies that suggest that you can integrate deep learning with sparse modeling. Thank you for tuning in to this webinar series on the comparison between deep learning and sparse modeling and its purpose.